Let's learn about the neuron. To better understand this process, our model has two parts, the electrical and the chemical. First, to the electrical. If I press this button, this signifies that a signal has just reached the axon hillock and it will travel down the axon. The strength and the size stay the same, only the frequency changes. Next, to the chemical. This neurotransmitter, acetylcholine, signifies that a stimuli has occurred and it will open the ligand-gated sodium channel so that the sodium goes from outside the cell body inside the cell body. If this stimuli is strong enough, the sodium from outside the cell will enter inside the cell with the voltage-gated sodium channels. In the meantime, the sodium from inside the cell body will be transported back outside of it again with active transport in this sodium pump. Next, our potassium will go from inside the cell outside the cell to change the charges. This will be a repolarization, whereas this was a depolarization. Once this occurs, the charges of this positive inside will change again, and it will be transported outside. At last, we will have our calcium ions here, and they will go from outside the cell inside the cell. And they will move to the axon terminal, where the signal will be transported to the next neuron. At last, to revert the charges as it was in the beginning, we have active transport in the sodium-potassium pump to bring it back to the way it was in the beginning. As you see, we're putting in energy as this is active transport. Any questions?
So what happens if the stimulus isn't strong enough? It doesn't reach the threshold?
This is an all or nothing phenomenon, meaning that if it doesn't cross the threshold, nothing will happen.
And what is the difference between a ligand-gated and a voltage-gated channel?
A ligand-gated channel needs a ligand to open it, whereas a voltage-gated channel needs a change in voltage. And that's what connects you to the world.